Hey quids, or kids, not quids. Anyways, real quick video. Rishi just asked a question about the bearing blocks and the widths in the slots for the tubing that they go in. I know Rishi's got it down, but I'm going to make this really short for the rest of you because it's going to help you make a West Coast drivetrain if that's the option you're going for. There's lots of other different drivetrain options you can do, but if you're trying to do West Coast, this will be pretty helpful. So West Coast Drive, you have your gearbox somewhere in here. In this robot, we have it in the back. Most of the times you can have it in the center. Uh, Ignore that. You'll have bearing blocks here, these little pieces that hold your bearings. There's two different types. There's the gearbox bearing block and the side bearing block. If you look in the future tree, it says WCD gearbox block. That's because that goes directly into your gearbox plates. The other two are called side blocks, as you can see here. Because if I click on that, it goes on both sides. On one end you have your sprocket and your shaft, and on the other end you have your wheel. In order to get these in, there's special types of slots and holes you'll need to make, so this video is going to detail that just a little bit. So if I open up this tube, see a lot of fancy holes in here. Left to right, this is where these three holes are just clearance holes for bolts for the gearbox. Those aren't related to the bearing blocks really. For the bearing blocks, is you have this for the gearbox side bearing block, which normally is in the center. You have a hole about 1.5 inches in diameter at about 3 thou for clearance. And then just center with that, you have these two holes, which are 196, and they're about 1.875 inches apart. And we're going to go into the sketch and see that in depth a little closer. Your side bearing block is going to look like this. You're going to have this one, the center one, is offset. Normally, like I said, that's the gearbox one, but you can see the center is a little bit lower because it actually touches the ground. Not usually a good thing, but I'm going to make it work with this robot. Try not to make it like this on your robots. You'll have a slot, or so you have a rectangle that's about 1 3/8 wide, 1 3/8 tall, sorry, 1.375, and usually add 2 thou to that for clearance. So 1.377, and then 1.875, 1 7/8 wide, add 2 thou for clearance, that's 1.877, you'll see those numbers in a bit. And you have these slots that'll allow the bearing block to slide back and forth. That's the whole purpose of it, so you can tension. These are 196 diameter, 098 radius. Slots sometimes go by radius, so make sure you check that when you put the dimension in. And their total length is about 3/8, so if I click on this, it's going to be half that, 3/16, 0.188. You'll see more into the sketch. You have a circle here. There's a dimension going to the center of the block, and it's about 1 7/8, and that's for your cam tensioner. It's what keeps the tension in the bearing block. And again, we'll see the dimension closer to that more in the sketch, and I'll go back to the drivetrain and show you what that does. Last one over here, we have another side bearing block. Same shape as this one. You notice it's a little higher, and that's because the center one's offset. Same exact thing copied over. Something to note is you always want the hole for your cam to be facing towards the gearbox plate. So for example, if my gearbox was in the middle, then whatever side bearing block is over here would have the hole on the right side, and the one over here will have on the left side because it's facing towards the gearbox. So now we're going to enter into the sketch where these were all made. Now I go a little bit extra. I model my wheel and my mounting holes. But if you see here, oh, and ignore this hole. This is for something different entirely. Over here we have our gearbox bearing block plate hole, 1.503 inches. It's just 1.5 with 3 thou added. 196 holes on either side, and those are 1.875 across, and the center of the line is centered right here with the origin of the hole, and that's just a midpoint line. Midpoint line I did. Yeah, midpoint line right there. Normal bearing block, 1875 total width, from one end to the inside. I recently learned a cool trick from one of the kids. Like, I think it was Chris. I was doing it the dumb way the whole time, where I would literally make two different slots of a slot on the left and a slot on the right, and then you know, treat them differently. Realized that wasn't necessary. One of the kids showed me. Yeah, so I just have a center point slot that goes out, radius 098, and then 3/16 from center to each edge, and that should define it perfectly. We have our hole for the cam, the mounting hole for that, and it's 1 7/8, 1.875 from the center. And my rectangle 1.877 long. Where is it? That's weird. That wasn't tolerance right. Oh no, you know what? That was tolerance right. Normally that would be 1.377, but because this one is so close to the edge, I really had to be careful on how I tolerance that. That's something I'm doing, but I would suggest you make yours 1.377. The oversize isn't going to hurt. And then it's the same thing over here. And you see there's not as many dimensions here because I just, use a lot of equal relations. Works out pretty well. You can see this one is in line with the bearing hole, and the center one is dropped by should be about 1/8 of an inch. Yeah, so it says 3/16 here because it's 3/16 off the origin. But if you look, this line is it's not at the origin. So this is actually a 3/16 total position there. So there's about a 1/16 between here and here. If I check down there, yep, that's 0.63. So it's an 1/8 inch total center drop. And exit out of that, and you have our nice little shapes there. And it works out for our drivetrain. We can see, change transparency. You can see the bearing block in there. It's in the slot. You see a sprocket, and here's the cam I mentioned. It's right at the nice position. You can see if we turn it a little more, let's say counterclockwise, it'll push the bearing block out. Mine doesn't move out because I have it on the width mate. But you can very much do a limit distance mate, for example, and limit distance between one edge and the other. And you can make it slide around if you'd like. It's just a bell and whistle. It doesn't really help you in design, so that's why I don't do it. Alright, so that should be all for this. Hopefully this helps you kids. Thanks for watching.